Hi, and welcome back, guys, to this our final section, final lecture. Wow, how crazy is that, eh? We have really learned a lot. I have enjoyed myself immensely. I hope you have as well. Any questions, feel free to contact me or your colleagues online because this is the important stuff. Go out there and make yourself a good PLSQL programming living because it's important that we keep this moving forward. All right, in this lecture, we are going to finish up functions and then packages. Important stuff. Packages are sort of where we're going to make our living going forward, so it's important we take a look. I'll see you on the inside.
As you'll recall, in Lecture 12 we took a look at our pick next play function. This function accepted a complex record structure representing the current play condition and based on that information made a decision as to the next best possible play to run. All in good fun, but still had some very important lessons for us to learn. In particular, Lecture 12 covered user-defined types, input and returned from a function, how to debug under complex data type input and output conditions, random number generation within a specified range, dynamic SQL, weighted random number generation, and finally, the value of subject matter experts, or SMEs. Okay, let's take a look at the code. Looks like this guy is going to accept a user-defined type paralleling a row from the game place table and returns a user-defined type which has the same structure as a row from the team plays table. Makes sense, right? We look at the current game conditions, and based on that information, we make a decision as to what's the next appropriate play. Any thoughts on that signature now that you know about overloading subroutines? Yeah, some calling languages may not be able to handle that level of data structure complexity. As such, if this were a real world, we would probably also create a second overloaded copy of this function, which pushed all these user-defined types down to their corresponding primitives. Remember, however, we debugged that routine with this complex data type parameters. Yeah, I set up a little calling routine, knowing that if I typed all that stuff into the debugger, I would almost certainly get it wrong. This was my little routine I wrote to test pick next play function. Remember, however, that both these routines must be compiled for debug for this technique to work properly. We then talked about an embedded function we created for calculating the cumulative area under a normal curve as a function of a z-score input. I've already mentioned that I'm not a great statistician. As such, when I need a routine like this, I go to the experts, subject matter experts. In our case, I found a routine online written by a Penn State graduate student. Now I'm a Big Ten graduate myself, so I have some faith in this guy's credentials. However, I still verified the output of his code against the same calculations in Excel because I never trust code coming off the internet. Ta-da! Our SME was in fact an expert. In fact, that was such a nice piece of code, I've added it to my little directory of these are nice pieces of code. What if you don't even know enough to validate an online routine? Find an expert. Do not blindly trust online code. We then moved on to look at some random number generation code. The code we are interested in started here with this explicit cursor for loop. Looks like we are filling an index by table with possible next play candidates based on some input parameters above. The next line of code here is where the magic happens. First thing to notice is the dbms underscore random.random function. Sure, this guy returns a random number within the range of plus and minus 2 to the 31st. Now we perform a modular arithmetic operation on that value based on the number of rows in our index by table. Aha, okay, that's clever. We then add 1 to that mod result to get back to a 1-based indices, and finally throw an absolute function at it to make sure all results are positive. Guys, that's good code. Alrighty, if you'll recall, we then went on to use dynamic SQL to select a play for second down. We began by building the base syntax for our select statement in a simple varchar variable. Using if-then-else logic, we then added additional conditionals to that base select statement. Finally, when we had our SQL statement properly created, we opened it with a reference cursor and 3 bound variables. Set up a loop to fetch rows from our reference cursor until the %NotFound condition is met. Come on, that's nice. Don't forget to close that reference cursor, or that guy will hang out there as long as your session exists. Also remember that with today's modern connection pooling, that session could hang around a long time, so make sure you close that cursor. Also, remember that we mentioned that your dynamic SQL does not have to be a DML statement. Here in this little example, we use dynamic SQL and the execute immediate command to even realize DDL. We culminated our discussion of the picks next play function with a look at weighted random selection. To make our example work, we assumed that one of our fields available to our analysis was a z-score. We then used our SMEs function to convert that guy to a cumulative percentile, and then with that value to populate our index by table in a weighted function. Guys, I know this one was a little tricky for some of you, but the takeaway was that having a weighted value in your set of available metrics, then you can use that value to determine the number of rows added to a local structure. You then have a weighted distribution in that structure from which you can select one, some, or all the rows. We chose to select just one randomly. Yeah, I was pretty proud of that paragraph of code, even if I had to borrow the code for the normal cumulative distribution. That was nice stuff. By the time we got around to lectures 13 and 14 on packages, you guys had a pretty good understanding of flow control, user-defined types, and Oracle supplied routines. It was time to learn how to put all those pieces together to build libraries of like-purposed subroutines and then their associated data structures. You know where I'm going. I'm talking packages. However, before we jumped into the deep end of the pond, we had a little setup work to do. Do you recall the way we created a copy of a table structure without copying over the rows? Hey, I know that's not truly PLSQL, but it's still worth mentioning because it's very darn clever. We, of course, started our discussion of packages with a generalized review of how they were defined. As shown here, the package signature contains all externally exposed data structures, subroutines, and optionally, any externally exposed exceptions. The package body contains any internally defined data structures, internally defined subroutines, and of course the definitions for all those externally exposed routines. Net, the package signature effectively defines a black box to the externally calling world. Coders utilizing these exposed routines don't really have to fully understand how they work. They simply have to know what they do and how to use them. Remember, when building your packages, that the local data structures and subroutines must precede any publicly exposed definitions which they might utilize in the body. Why is all this important anyway? Remember, every organization has business secrets. How are those managed within Oracle? Behind the black box subroutines of a package. Similarly, everybody's a junior programmer at some point in their career. Senior programmers don't want to expose advanced logic and data structure techniques to the people too quickly. How to get around this issue? Hide those advanced techniques behind a black box package. Everybody's productive, everybody's happy. Okay, we then went through a package signature definition ourselves. We had a couple of externally exposed data structures, some externally exposed subroutines, and even one procedure, the create user procedure, which was overloaded. That is, it had multiple dissimilar signatures. If you'll recall, it's sometimes necessary to overload subroutines in order to support differing calling language. Some are simply not sophisticated enough to pass complex user-defined types. I'm sure none of you was very surprised to see how we define the package body. Sure enough, create or replace package body, package name as. Remember, we also had a brief discussion at that time on the relative benefits and dangers of global data structures. Me, I use them because it keeps my past parameter lists much smaller. The academics will tell you it's a horrible idea. It's up to you. We culminated that discussion with a look at the internally defined package subroutines. Remember, here's where the top secret stuff can live, as external coders can't even see the name or signature of these guys. Junior programmers don't need to know they exist. As you can probably tell, I'm a huge advocate of this approach. Give everybody access to that information, but know exactly how that access is being realized. In Lecture 14, we moved on to discuss our package body details. After a brief review of the potential dangers of globals and the need to always explicitly commit your transactions, we moved on to audit tables and how most online applications actually don't individually log users onto the database. Instead, users are tracked through a session-level user ID normally maintained by the web server. This user ID and the current timestamp are then added to audit tables to track important changes. Also remember, we indicated that how that session variable is maintained by the web server and passed to the database is very much a function of the software platform you're using. IIS and .NET are going to work entirely differently than Apache and Java, so do yourself a favor and Google that configuration information before you jump in. In our next internal subroutine, we used a union operator to get the superset of rows from two tables. Now, I know this is officially not PLSQL, but I wanted to give an example of what I would consider code which was too complex for newbies. Trust me, the union all, and intersect operators are definitely not to be used by those just starting out. Just too dangerous. Psst. Would you have known how to get that superset? If the answer was no, maybe you need to check out my Oracle SQL course. We get pretty deep. We then moved on to a routine which used the util SMTP and the util TCP Oracle supplied packages to write an email to users who had forgotten their password. Our example was specific to this narrow application, but going forward you might want to make that code a little more generalized and then add it to your library of standard utilities. Remember, however, that your SMTP host and port need to be specified according to your specific network environment. That may require a call to your local systems people, not something most programmers are going to know. By the way, don't forget to close that TCP/IP pipe and close the SMTP connections. Easy one to let slip. We concluded our discussion of packages with a look at internal procedure which registered a user's device to the database. Again, another really nice piece of code and probably one you want to store off to that collection of nice stuff. Remember, that guy simply leveraged the user environment parameter of the syscontext function to get the IP address and the OS of the user's box. Pretty nice example and clearly about as real world as you can get.
Hey guys, talk about bittersweet. That is the end of our content for PLSQL programming, real world examples. I had a great time. I hope you learned a ton. I hope you take this information and go out there and just build a better life for yourself, because you know what? That's why I do this. As to next steps, you should be eligible at this point to print a certificate of completion for this course. I hope that proves very valuable in your careers going forward. As to my next steps, as some of you may know, this is my 4th course on Udemy, and I've had just a great time. I'm going to continue doing it. My next course will come out in late fall of 2017, and will deal with XML and PLSQL as a asynchronous communication and data storage environment. Very important stuff and very germane in today's real world programming environment. I hope you check it out. In addition, you want to learn and see more, check me out on digitalmiddleage.com, because that's really my website, and that's sort of where I live. In the interim, go out there and have yourself some fun, but learn something new every day, because it's what's important. Bye-bye.